Okay, welcome to section 3.6. This will be your last section in chapter 3 before you take your test. This section is about syllogistic arguments and Euler diagrams. So a syllogistic argument is another form of argument. A lot of times it'll just be called a syllogism. And the way you test the validity of a syllogistic argument is by doing what's called an Euler diagram. So an Euler diagram is a method that uses the universal set, which will look like just a big rectangle. And then inside of it, they're going to represent sets with circles. And you just draw the sets based on their description, and you see if the conclusion is valid or invalid based off the shapes that you draw. So it's easier to show you with an here. So we've been doing symbolic arguments so far. Symbolic arguments typically use the words like and, or, not, if then, if and only if. Those are the ones that you can do with your P's and Q's. And you can prove those by using truth tables, or you can look at the standard forms that we talked about in section 3.5 to test whether an argument is valid or invalid. Syllogistic arguments are a little bit different. They include quantifiers, words like all are, some are, none are, some are not. If you start using quantifiers, then the way that you prove whether something is valid or invalid is by using an Euler diagram. So this would be an example of something that you could encounter on your homework. So determine whether this is valid or invalid. All ballerinas are athletic. Kishan is athletic. Therefore, Kishan is a ballerina. Okay, so what would that look like if you were going to make an Euler diagram? Okay, so first thing you would do is you would draw your box for the universal set. And the universal set we can just say be people, okay? And we talked about that all ballerinas are athletic. Okay, so that means that you're going to need a circle for ballerinas. Okay, well, all of the ballerinas are athletic. So you're going to need another circle around the ballerinas for athletic people. And since all of the ballerinas are athletic, the ballerinas are going to be stuck completely inside of the athletic circle. Okay, now, according to this, Kishan is athletic. So, does that mean that Kishan has to be a ballerina? Do we have to put Kishan here in the ballerina circle in order for him to be athletic? And we do not. Kishan can be athletic and not be a ballerina. So you can put him between the blue and the red bubble. So because Kishan is not forced into the ballerina bubble, this would be an invalid argument. Kishan does not have to be a ballerina just to be athletic. Let's look at another example. Okay, determine whether the following is valid or invalid. Okay, no parrots eat chicken. Fletch does not eat chicken. Therefore, Fletch is a parrot. Okay, so let's see what that looks like. Okay, so we'll draw our universal set. Okay, they usually label that with a U. And then it says that no parrots eat chicken. That means the parrot bubble and the chicken bubble are completely separate. They do not intersect because there's never a time where a parrot eats a chicken. Okay, so you've taken care of your first statement. So it tells you that Fletch does not eat chicken. Does that mean Fletch has to go in the parrot bubble? Fletch could be a parrot, but could Fletch also go on the outside in the universal set? Fletch could be on the outside. The outside in the universal set are also items who don't eat chicken. So Fletch is not forced into being a parrot. Fletch can be, but he's not forced to be. So because he's not forced to go into the parrot bubble, this is an invalid argument again. Okay, let's look at another one. Okay, so here's another example. All A's are B's. Some B's are C's. So some A's are C's. Okay, let's see if that's valid using an Euler diagram. So, since all A's are B's, that means the A bubble is going to be stuck in the B bubble completely. Okay, so all of the A's are part of the B's. Now, it says some B's are C's. So there's a couple different ways that this can look. You could have like just a little edge of the B's be part of the C's. If you wanted, you could go all the way over and get some of the A's as well and have that be part of the C's. But you don't have to, okay? So, oops, I erased my whole thing. So, are we forced, if all of the A's are part of the B's, are we forced that some of the A's have to be part of the C's? No, we're not. You are allowed to have some B's be part of the C group and not have that include any of the A's. So again, this is an invalid argument. Okay, last example. No fish are mammals. All cows are mammals. So no fish are cows. All right, let's draw that image. We'll start with our rectangle. No fish are mammals, so that means that fish and mammals are completely separate, disjoint groups. All cows are mammals, so that means all of your cows have to be stuck in the mammal bubble. So therefore, no fish are cows. Did you get any situation where the fish and the cows intersected each other? You did not. There is never that case. So this is, in fact, a valid argument. Okay, good luck with your homework.